Bismillahirrahmanirrahim. Assalamualaikum to everyone. My name is Muhammad Haikal bin Awaludin and my student ID is 2021450886. And today my teammates and I will be present about forward-backward methods. In mathematics, a statement is a sentence that is either true or false. Meanwhile, a proof is a convincing argument expressed in the language of mathematics that a statement is true. The first very step in doing proof is to identify the hypothesis A and the conclusion B. So, what is the meaning of forward-backward methods? The forward-backward proof techniques are generally used to establish the if A true, then B true, where A and B are statements. When right to prove, we must use forwards method. Start from the assumption A to reach the conclusion B by going through several clear and logical arguments. In attempting to figure out just how to reach the conclusion, we need to use backward methods. In backward process, you begin to ask a question and answer it until the key question cannot be asked or cannot be answered. By asking the such question using information backward process, you can call the provided in the assumptions. Generally, the forward-backward method is probably the first method to try a problem unless you have the reason to use different approach. Now I will be explain about general outline forward-backward methods. First step is solving forward-backward methods is recognizing what is the hypothesis and what is the conclusion with statement A and statement B. For the second step is improving A implies B. We must somehow assume that statement A is true and use any formula or information related to reach the conclusion that B is true. Next step is use the backward methods until the last statement derived from backward method is obtained. Last step is write the proof by starting with A, then those statements derived by forward method, and then those statements in opposite order derived by the backward method.
Hello and Assalamualaikum. My name is Muhammad Nabi Hakimi bin Cik Fizal. My student ID is 2021845796. Alright, now I will show you some example question related to forward-backward method. We will do a simple question first, so you guys can understand this topic slowly but surely. Example 1. Proof using the forward-backward method that for integer n, if n is an odd integer, then n squared is an odd integer. Write the analysis of proof and the condensed proof. So, the first step is identify the statement. Step 2 is use backward process, and step 3 use forward process until the backward and forward are equivalent. Solution: analysis of proof. So the first step is identify the statement. N is an odd integer is statement A, and squared is an odd integer is statement B. So we write the statement A and B. N is an odd integer is hypothesis. B and squared is an odd integer is conclusion. Step 2. Use the backward process. B1 n squared equal to 2k plus 1 for some integer k, according to the definition of odd integer. So the step 3 is use forward process until forward and backward are equivalent. According to statement A, we use the definition of odd integer. So the A1 is n equal to 2a plus 1 for some integer A. A2, we also use the definition of odd integer. So the A2 is n equal to 2b plus 1 for some integer B. So A3, we need to substitute n equal to 2a plus 1, n equal to 2b plus 1. So the n squared is 2a plus 1 times 2b plus 1. So we get for AB plus 2a plus 2b plus 1. So we need to factor out, then we get 2 times 2ab plus a plus b plus 1. So for the a4, we need to simplify a3. N squared equal to 2k plus 1, where k equal to 2ab plus a plus b. So the statement a4 is equivalent to b1. So from the question, we need to write the condensed proof. From the hypothesis, n is odd, then n equal to 2a plus 1, n equal to 2b plus 1 for some integer a and b. Since n squared equal to 2a plus 1 times 2b plus 1 equal to 2 times 2ab plus a plus b plus 1 equal to 2k plus 1 for some integer k equal to 2ab plus a plus b. Therefore, n squared is an odd integer. So I will pass to the next person.
Hi, my name is Nabil Najmi. My student ID is 2021-840532, and I'll be present for example 2. For example 2, the question is, if p and q are even integers, then 3p squared plus pq is divisible by 4. A. P and q are even integers as a hypothesis. B. 3p squared plus pq is divisible by 4 as a conclusion. B1. 4 divided 3p squared plus pq. 3p squared plus pq equals to 4k for some integer k by the definition of divisibility. For the forward process, A1, p equals to 2m, q equals to 2n for some integer m and n as a definition of even integer. A2, 3p squared plus pq equals to 3 times 2m squared plus 2m times 2n equals to 12m squared plus 4mn equals to 4 times 3m squared plus mn equals to 4k, where k 3m squared plus mn. A2 equivalent B1. So the condensed proof is, given that p and q are even integers, then p equals to 2m and q equals to 2n for some integer m and n. Since 3p squared plus pq is divisible by 4, then 3p squared plus pq equals to 4k for some integer k. Therefore, 3p squared plus pq equals to 3 times 2m squared plus 2m times 2n. Then there exists integer k such that 3p squared plus pq equals to 4k, where k equals to 3m squared plus mn.
Hi, my name is Muhammad Febri Magaman. My student ID is 2021837974. So I will explain about example 3. For example 3, I will show you how to do forward and backward process for the proposition of triangle and its perimeter. For the example 3, the question is, if triangle XYZ is right isosceles triangle, then the perimeter of the triangle XYZ is square root 2 plus 2 times a congruent side. From the question, we can find the hypothesis and conclusion, and from the question, we also can find the congruent side, which is XY and YZ, because it has the same value. For the solution, A. Triangle XYZ is right isosceles triangle, which is the hypothesis. B. The perimeter of the triangle XYZ is square root 2 plus 2 times XY, which is the congruent side, and this statement is for the conclusion. For your information, not all questions use the backward process. For this example, we use the forward process. So the step is A1, xy equal to yz. This is the definition of isosceles triangle. A2 perimeter equal to xy plus yz plus xz. This is the perimeter equal to 2 sides plus 1 base. A3 xz square equal to xy square plus yz square. A4 xz equal to square root of xy square plus yz square. This is the Pythagoras theorem. For the A5, the perimeter equal to xy plus square root of xy square plus xy square. This is the substitute A1 and A4 into A2 and simplify until reach B. So we need to simplify this until we reach B. So we reach B. A5 equal to B. For the next, the condensed proof. From the hypothesis xy equal to yz, by using the Pythagoras theorem, xz square equal to xy square plus yz square. Obtain xz equal to square root of xy square plus yz square. By formula of perimeter, xy plus yz plus xz equal to xy plus xy plus square root of xy square plus xy square equal 2xy plus square root of 2xy. One obtained perimeter xyz equal to square root of 2 plus 2xy. That's all from me. So we go to the conclusion.
In conclusion, the basic method to construct a proof is the forward-backward method. Your goal is to write out the proof and form a logical path from the things you are given A to the thing you are trying to prove, which is B.